Hello guys, welcome to my new video. In this video, I'm going to talk about physics tech talk, quantum networking and internet working. I am Vedant Shavakla and my roll number is 22951 APT55 and I'm from CSID A section. So without any further ado, let's move into the topic. Sakai. Internet working. Internet working is combined of two words, inter and networking. It implies an association between totally different nodes or segments. This connection area unit is established through interface devices akin to routers or gateway. The first term for associate degree internetwork was CATNet. This interconnection public is often among or between public, private, and commercial, industrial, or governmental networks. For associate degree, internetwork could be assortment of individual networks connected by intermediate networking devices that function as one giant network. Internet working refers to the trade, products, and procedures that meet the challenge of making and administering internet works. So let me hide this floating meeting controls. To enable communication, every individual network, node, or phase is designed with a similar protocol or communication logic. That is, Transfer Control Protocol (TCP) or Internet Protocol (IP). Once a network communicates with another network, having constant communication procedures, it's called Internet working. Internet working was designed to resolve the matter of delivering a packet of information through many links. And here is an image related to the about text. Next slide. Internet working, merely exploitation of either switch or hub to attach to local area networks, is an extension of LAN. There is a minute difference between extending the network and internet working. Merely exploitation of either a switch or a hub to attach to local area networks is an extension of LAN, whereas connecting them with via the router is an associate degree. Example of internet working. Internet working is enforced in layer 3 network layer of the OSI ISO model. The foremost notable example of internet working is the internet. There is a minute difference between extending the network and internet working. Merely exploitation of either a switch or a hub to attach to local area networks is an extension of LAN, whereas connecting them via the router is an associate degree example of internet working. Internet working is enforced in layer 3 network layer of the OSI ISO model. The foremost notable example of internet working is there is three units of internet working. Intranets and extranets might or might not have connections to the net. If there is a connection to the net, the computer network or extranet area unit is usually shielded from being accessed on net if it is not authorized. The net isn't thought about to be a section of the computer network or extranet, so it should function as a portal for access to parts of the associate degree extranet. Extranet is a network of the internet network that's restricted in scope to one organization or entity. However, that additionally has restricted connections to the lowest level of internet working, usually enforced in an exceedingly personal area. Associate degree extranet may additionally be classified as a man, WAN, or different form of network. However, it cannot encompass one local area network. That is, it should have a minimum of one reference to associate degree or external network. Intranet, uh, Intranet, the associate degree computer network could be a set of interconnected networks which exploits the internet protocol and uses IP-based tools akin to web browsers and FTP tools that are underneath the management of one body entity. That body entity closes the computer network to the remainder of the planet and permits solely specific users. Most typically, this network is the internet network of a corporation of specific users, of a different enterprise. An outside computer network can usually have its own internet server to supply users with browsable data. Actually, this slide is very big, so I'm going to skip this slide and I'm going to leave 5 seconds for you to read this slide. Yeah, let's move on to the next slide. This slide is also quite big, but I'm still going to read this slide as I skipped the previous slide. Quantum networking. 4 years, 4 months, and 12 days ago, photon of particle light left Proxima Centauri, the closest star to us. Just now, it finally arrived at the Earth. This photon and others that have come with it could reveal incredible secrets about the planets that orbit the red dwarf star, such as if they are not habitable or even inhabited. However, with current instruments, we are not able to tease out this information. That could one day change with the technology called quantum networks. Quantum networks are like the classical networks we use in everyday life to transmit and share digital information. However, quantum networks use quantum bits of qubits which encode information in a way that is utterly foreign to the classical way of thinking. Qubits use tricks from the weird world of quantum mechanics and are fundamentally different from classical computing qubits. And when employed on quantum networks, they are radically more powerful. What is quantum network? Quantum networks are going to change the world, just like the internet led to a revolution in computing and society more broadly. Experts expect the quantum internet to have a profound impact on how we live our lives. Countries around the world are already racing to lead the pack in the emerging field. Despite all this excitement around us, quantum networking technology, few know what it actually means. Quantum networks communicate quantum data usually stored in the form of individual photons. By using the power inherent in quantum states, quantum networks can enable new applications like physics-based unhackable security, more powerful quantum networks that can solve tasks in minutes that would otherwise take years, and networks of entangled quantum sensors. How does a quantum network work? Quantum networks take advantage of the power of a quantum mechanics, the strange physical properties that only appear at very small scales, like individual particles using individuals, photons. Quantum networks create entangled quantum states across the globe. Qubits, entanglement, and quantum repeaters make up some of the building blocks of how quantum networks work. What is a qubit? A qubit is a qubit. Qubits are the building blocks of quantum data, where a classical bit must be either a 0 or a 1. A qubit can be in a superposition of both 0 and 1. In addition, qubits are the same property that once measured, they have probabilistically collapsed to either a 0 or 1. For example, if we measure a qubit in equal superposition of 0 and 1, there will be a 50-50 shot of measuring either state. On top of this, multiple qubits can become entangled. What is entanglement? Entanglement is a phenomenon in which the two qubits become interdependent on each other even when separated. Entangled qubits can seem to be instantaneously tied. Entanglement is a tricky concept. It has tripped up students and teachers alike for decades. Even Einstein struggled with quantum entanglement and famously rejected the concept. However, we know that the quantum particles like photons do become entangled with quantum networks. We can use this unique property of quantum states to enable new powerful applications. By taking advantage of the properties of quantum mechanics like superposition and entanglement, quantum networks can enable new applications that are not possible on today's networks. What can quantum networks do? Quantum networks can enable physics-based ultra-secure communication, the more powerful quantum computers and better quantum sensors. Just as the creators of the ARPANET could not have only predicted the many ways in which we use the internet today, there are likely to be many more applications of the quantum networks that we cannot imagine until we build them. What's the next step for quantum networks? The race is on to build the first practical quantum networks. In 2020, the US announced a blueprint for the quantum internet, which always lays out a plan to build the first degree large-scale quantum networks in the US. Similar efforts are underway around the globe, such as the Quantum Internet Alliance in Europe. To build large-scale networks, we first need to solve some core technical problems like designing a network stack and building quantum repeaters to extend communication across long distances. Alidus projects offer tools to enable better design and testing of these foundational components to better simulation and emulation of quantum networks. And this slide is very big, and I'm going to skip this slide. And this slide is also very big, but I'm going to give you 5 seconds to read this slide. Thank you for being patient for 10 minutes and listening to my nonsense. And I wish you all the best. Have a good day. Thank you.